Alright, one of the first things you have to learn for AP Chemistry is solubility rules. I'm sure you guys learned it last year in honors chemistry. Basically, solubility rules, if you look at an ionic compound, which is going to be a metal in the front, a metal, let me get this set, a metal in the front, and a non-metal in the back, or an ion. They're ions. If you drop them into water, do they break apart into the ions? Na plus, Cl minus. So that's really what you have to do is use a series of rules to apply and look at it. Now I know this is soluble. How do I know this is soluble when I drop salt in water? Obviously you know you can make salt water. But if you look at the first solubility rule, anything with a group 1 metal in the front is always soluble. So for example, if I have Ki, potassium iodide, the fact that the group 1 metal is the first ion, anything with a group 1 metal is always going to be soluble. So if you look at the periodic table, the leftmost group is the group 1 metals, 1A metals, or that's group 1. So any compound that has a group 1 metal to start, or the salt ammonium, NH4, is always soluble, always. So for example, NH4I, ionic compound, if you look at the front of it, the fact that it has NH4 in the front means it's always soluble according to these rules. Next set of rules involves Cl, Br, and I minus. They are all anions. They occur on the back of an ionic compound. So for example, you could have AlCl3. Is this soluble? Well, using the rule, you focus in on the chloride. All chlorides are soluble except if it's one of those three. If it's one of those three, we consider it to be insoluble. So the rule is you learn for chlorides, Cl minus are all soluble except those three exceptions. Br minus, always soluble except those three exceptions. Oops, the one down there. And I minus are all soluble except those. If you notice, they're the same ones. If you have Ag, Hg, or Pb in the front as a metal, they're going to be exceptions to the solubility rule. It's supposed to be Ag, it's kind of written funny. So they're always going to be insoluble. Next one, third solubility rule, chlorates and nitrates and acetates are always soluble. So for example, if I have Pb, parentheses, NO3, parentheses 2. If I look at that, how do I know that's soluble or not? The fact that it contains a nitrate automatically makes it soluble when you're applying solubility rules. So you need to know that always. So far we learned the first rule was any group 1A metal is always soluble, ammonium. The third rule has to do with anything that has a chlorate, a nitrate, or an acetate at the end of it. Will always be soluble. Fourth rule requires the most memorization. Most sulfates are soluble. The exceptions are Ca, Sr, Ba, Hg, either plus 1 or plus 2, Pb, and Ag. Those are the ones that are going to be insoluble. If you remember from the previous slide here, Ag, Hg, and Pb have a tendency to already be insoluble. So really, you've seen the Ag, you've seen the Pb, and the Hgs. So then the only other thing you have to remember is these three are insoluble when they're combined with sulfate. I remember it by CBS. Think of it that way. Calcium, barium, strontium. They're all 2 plus. If they're put together with an SO4 at the end in an ionic compound, they're insoluble. They won't break apart. Next one. These are always considered insoluble. Phosphate, carbonate. So for example, FeCO3. If I look at that and want to determine whether or not it's going to be soluble or not, I know that all carbonates are insoluble except, it goes back to rule 1, if NH4 or a group 1A element is in the front, and it's not. So therefore, we would consider this I or insoluble. What about K3PO4? We know that all phosphates are insoluble, but it goes back to rule 1. Rule 1 gets applied first. The fact that potassium, if you look at it in the periodic table, is in the group 1 of the periodic table, the first column in the periodic table, they're always insoluble. So this will actually break apart, and you would consider this, give this a little S subscript, meaning not a subscript, actually, that's a bad idea, but S saying it's soluble. Next one, all metal oxides, anything that has O2 at the end of it, or O, excuse me, any oxide. So for example, FeO, soluble or insoluble? Well, we know anything that has O at the end of it's going to be insoluble except NH4 and a group 1 metal. Fe, if you look in the periodic table, is not a group 1 metal, therefore this will be insoluble. Last but not least, actually this isn't the last one, hydroxides. Anything that has a hydroxide is considered insoluble, except, again, goes back to rule 1, anything with NH4 plus, or group 1, or group 2 from calcium down. So anything below calcium on the periodic table down is considered to be insoluble, soluble. So anything from calcium down is considered to be soluble. Looking at the second one. Last one, sulfides. Anything that has a sulfide at the end of it, an S, is going to be insoluble. Goes back to rule 1. If you look right there, we have NH4 plus, or anything in a group 1A or a group 2A is going to be soluble. So for example, MgS has a sulfide at the end of it. We look here, magnesium is actually in group 2A. You use your periodic table, you realize that it technically, in that case, would be soluble. Now, let's take a look at a couple. What if I told you MgSO4? I give you this ionic compound. Soluble or insoluble? Well, if you look, you have SO4. You go back to the rule. What's the rule for SO4? If you look, the rule for SO4 is all sulfates are soluble except these 6 exceptions: mercury, lead, silver, and CBS, calcium, barium, and strontium. So if I go back here, that is not one of the exceptions. Therefore, if I put MgSO4 in water, we would classify it as being soluble. It would break up into Mg2 plus, SO4 2 minus. What about AgCl? Soluble or insoluble? Well, we'd have to go back to the rule with the chlorides. If you look right here, all chlorides are soluble except Ag, Hg, Hg2Cl2, and PbCl2. Is that one of the exceptions? Yes, it is. It is considered one of the exceptions because if you look right there, it has the Ag. Therefore, we would say this is going to be insoluble. So the key things if you're learning solubility rules is really to focus on learning the exceptions. Now we have a quiz star that you guys are supposed to sign up for. It's like 20 questions long. You have to go through and using the solubility rules. I sent you an email with a copy of them. You're expected to go through and be able to classify compounds as being soluble or insoluble based on the elements that are there. And really, again, the key thing is to focus on the exceptions for each of them. What are the exceptions for each of the rules? Know the always. These are always, so if you get that down, that's a good one. If you look right here, chlorates, nitrates, acetates. Acetate, remember, can also be written C2H3O2. So for example, you could have AgC2H3O2. If you're looking, anything that has acetate will always be soluble. And that is how you apply the solubility rules. There's 8 key ones. If you go through, especially learn the exceptions, make study cards, whatever it is you need to do, get them down because they're very useful and they occur a lot in AP chemistry.